Hi, we are going to discuss the distance formula today. This is how you can find the distance between 2 points on the coordinate plane. So the formula is based on the Pythagorean theorem. So if we have 2 points x1, y1 and x2, y2, we can form a right triangle by connecting all that in this way. It doesn't really matter where the 2 points are located with respect to each other. The important thing here is that the horizontal distance between the 2 points will be determined by the difference between the x-coordinates, which we'll take with the absolute value, because if we don't know which one is bigger, we want to make sure we get a positive value. And vertically, the distance between this distance is going to be determined by the difference between the y-coordinates. So we have a right triangle, which means this square plus this square equals this square. So we're going to write that. Then we're going to write that c squared equals a squared plus b squared. In our case, this will be d squared, because that's what we call distance. And here we're going to have the absolute value of x2 minus x1 squared plus the absolute value of y2 minus y1 squared. Because we're squaring, we don't need the absolute value any longer, so we can rewrite it without the absolute value. So it's going to look like this. And now what we can do is we take the square root to find the distance, because this is distance squared. So when we do that, we are going to get the following formula. And this is what we know as the distance formula. That's the one that we are going to use. And let's go ahead and take a look at some examples. So the first example here is find the distance between these 2 points. What we normally do is we identify the coordinates as x1, y1, and then x2, y2. And then we just substitute everything into the formula. Then the distance is going to be the square root of x2 minus x1, so it's 2 minus negative 1 squared, plus y2 minus y1, that's 7 minus 3 squared. So all that is going to give us, this is 2 minus negative 1, that's 3 squared, plus 7 minus 3 is 4 squared. It's going to give us square root of 9 plus 16, which is square root of 25, and that's 5. By the way, if we're going to run into any problems where the answer is not going to be a whole number, we will round them to the nearest hundredth. Okay? Let's go ahead and take a look at the next example. So the distance between these 2 points, again, we label them as x1, y1, and x2, y2. It doesn't really matter which one you label as what. Well, I mean, x and y, of course, matters, but which one of them is going to be x1, this one or that one. And then we're going to substitute that into the formula. So x2 minus x1 is going to be 10 minus 5 squared, plus y2 minus y1, 10 minus negative 2 squared. So that's going to give us 5 squared. That's going to give us 12 squared. And that's going to give us altogether square root of 25 plus 144, which is going to give us square root of 169, and that is the 13. Moving on. These 2 points, label them. So the distance is the square root of 5 minus negative 1 squared plus 3 minus 0 squared. So that's going to give us 5 minus negative 1 is 5 plus 1, which is 6 squared, plus 3 squared. So that's going to give us square root of 36 plus 9, which is the square root of 45. So now this is not a perfect square. There are 2 different ways we can write this answer. If we want it to be exact, we're going to write that in a simplified form, which is going to be 3 square root of 5. If we want to approximate that, we are going to take the square root of 45 using our calculator, and it's going to give us 6.71, or 6.71 rounded. Okay, so this answer is okay if we want a decimal. This answer is okay if we want the exact value here. Next problem, x1, y1, x2, y2. The distance is the square root of 7 minus -4 squared plus 14 minus -2 squared. So this is going to be 7 plus 4, which is 11 squared. This is 14 plus 2, which is 16 squared. So it's going to be the square root of 121 plus 256. So that's a square root of 377. And the square root of 377 is going to be 19 point. So it's going to be approximately 19.42. All right. So that's actually a pretty easy work to do. There's really nothing challenging here. You just need to do the arithmetic right, and then just make sure that all the computations are correct, and then carefully take the square root and round it correctly if needed. Right, so our last example here, we want to use this to find the perimeter of the triangle. I want to remind, the perimeter of a shape is the distance all the way around the shape. So what we're going to need to do is we're going to need to find the distances between all 3 points. So between this point and that point and that point and that point. So I'm going to label this point. Let me call this point A, this one B, this one C. So I'm going to do AB, which is going to be the distance between points A and B. I don't want to label them as x1, y1 because it's going to create confusion because I have 3 points. So I'm just going to set it up correctly. The idea here is that you're taking the difference of the x coordinates and square that, and then plus the difference of the y coordinates, which you're going to square as well. So we can do 9 for the x coordinate, 9 minus -3 squared plus 3 minus -2 squared. Let's go ahead and figure that one out. So it's going to be a square root of 12 squared plus this is 5 squared, which is going to be a square root of 144 plus 25, 169, and that's going to be 13. Okay. For BC, it's going to be the square root of the distance between the x coordinates, so -3 minus 1 squared plus the difference between the y coordinates, -2 minus -5 squared. Okay, this is going to give us, this is -4 squared plus this is going to be -2 plus this is going to be 3 squared. So it's going to be square root of 16 plus 9, square root of 25, which is going to be 5. And finally AC. So again, we're doing the same exact concept. We're going to take the difference between the x coordinates. So for AC, 9 minus 1 squared plus, and for the y coordinates is going to be 3 minus -5 squared. So what do we have here? We're going to have, this is 8 squared, plus this is going to be also 8 squared, right? And that's going to give us square root of 64 plus 64, square root of 128. That's not a perfect square, so, but I'm going to keep it like that for now. So for the perimeter, we're going to do 13 plus 5 plus square root of 128, which by the way, square root of 128, I'm sorry, square root of 128, square root of 128 simplifies as 8 square root of 2. So I can write that as 13 plus 5, hold on, I can do this math in my head, 18 plus 8 square root of 2, this is going to be in the exact value. And if I want to approximate that, I'm going to do 18 plus square root of 128. I'm going to get the decimal for that, or it's It's going to be 29.31 approximate. So that's all there is to it. It's a pretty easy formula to use, and I hope this was helpful.